What if a machine could look at you, hear your voice, and decide what to do next, faster than any human ever could? That idea sounds like science fiction, but it is already part of everyday life. In the United States right now, robots and AI systems are driving cars, screening job applications, helping doctors detect disease. This shift is happening fast, and behind it is a group of engineers whose job not just to build machines. As AI becomes deeply embedded in American society, understanding how this training works is no longer optional. At the heart of this topic is one central question. How do engineers actually teach robots to understand the world around them? Humans see, hear, and think naturally, but machines do none of this on their own. Everything must be carefully designed, trained, and tested. Let's start with vision when a robot sees. It does not experience images the way humans do. Engineers begin with cameras that capture raw pixels, just numbers representing light and color. On their own, those numbers mean nothing. To give them meaning, engineers use massive data sets containing millions of labeled images. A self-driving car, for example, is trained on countless photos of roads, pedestrians, traffic lights, bicycles, and stop signs. Each image is tagged, so the system can learn patterns over time. Gradually, the robot becomes better at recognizing objects. In new situations, even if lighting or angles change, this is how warehouse robots identify packages, how facial recognition systems work, and how AI helps doctors detect early signs of cancer. The key detail, however, is that robots are not understanding images. They are calculating probabilities based on patterns they have seen before. Hearing is just as complex. Human speech is full of accents, emotion, background noise, and context. Engineers teach robots to hear by breaking sound into data, frequencies, pitch, timing, and rhythm. AI models are trained on thousands of hours of recorded speech from diverse speakers. Voice assistants like Siri or Alexa convert sound waves into text, then predict what the speaker likely meant. In the real world, these systems transcribe medical conversations, power customer service hotlines, and assist people with disabilities. But again, hearing does not mean comprehension. The robot is not aware of meaning or emotion. It is making statistical guesses based on prior examples. Thinking is where the conversation becomes more serious. Robots do not think the way humans do. Engineers teach decision-making by defining goals and training models on historical data. A delivery robot might be taught to reach its destination quickly, while avoiding obstacles and staying safe. Through simulations and real-world testing, it learns which actions produce better outcomes. In finance, AI systems help decide who qualifies for loans. In healthcare, they help prioritize patients. In law enforcement, some systems estimate risk levels. These decisions feel intelligent, but they are built entirely on patterns from the past, not moral reasoning or empathy. One powerful technique engineers use is reinforcement learning. This works a lot like training an animal. The robot tries an action. If the result is good, it receives a reward. If the result is bad, it receives a penalty. Over time, it learns which behaviors maximize rewards. This is how robots learn to walk, how AI mastered complex games like chess and Go, and how logistics robots optimize their routes. Engineers don't control every move. They design the rules, the environment, and the incentives. Here's the part most people don't expect. When engineers teach robots, they are also teaching them human bias. If the data reflects inequality or discrimination, the robot will absorb it. A vision system trained mostly on lighter skin tones may struggle to recognize darker faces. A hiring algorithm trained on historical company data may repeat unfair hiring practices. Robots do not correct society's flaws. They amplify them unless engineers actively intervene. There are clear benefits to this technology. Robots can process massive amounts of information, operate non-stop, and at the same time, there are serious risks. Robots lack empathy and true understanding. They can make harmful decisions at scale. And when something goes wrong, responsibility becomes blurred between engineers, companies, and machines. This is where the emotional weight of the issue becomes real. Imagine a robot deciding which patient receives treatment first, or how a self-driving car should respond in a life or death situation. These are not distant future scenarios. They are design decisions being made today. Teaching robots to see, hear, and think is ultimately about teaching them what we value and what we are willing to sacrifice. So the real question is not just how engineers train robots, but what kind of world we are training them to create. If machines are learning from us, what exactly are we teaching them? And who should have the authority to decide how much power they hold? I love to hear your perspective in the comments. If this video helped you better understand how robots learn and why it matters right now, consider liking the video and subscribing for more deep